In this section, we will study math functions and its attributes. This is preparation knowledge for learning function limits. We will also learn number sequences and series and their attributes. This is also the foundation for studying the limit of sequences and series. Let's start with math functions. So, you can write functions as y equals to fx. You can write it like this. Now here, x is the input, or you can call it the independent variable, and y is the output. You can call that the dependent variable. So x is independent and y is dependent. Now, the reason is because the value of y depends on what the value of x is. Now, in a function, for a certain input x, you should only get one output of y. So this is okay, right? For one value of x, you get one value of y. However, if you have it so that one value of x gives, for example, two values of y, then this is not a function. So here, if you input x and you get y1 and y2 at the same time, then this is not a function. If you have two different values of y for one certain input, you're not getting a function there. However, this is good. This is a function, right? Now, this is not to be confused with if different values of x gives you the same value of y. So for instance, let's say that a certain input x1 gives you y, but also a certain input x2 also gives you y. Is this a function? Yes, because here, this x1 gives only one value of y, and x2 also only gives value of y, one value of y. Now, yes, these two give the same value, but that's okay. As long as it's one value of x for one value of y, that's good, right? However, for example, if we put x1 and you get like y1, y2, and y3 where they're all different, if you get this from x1 all at the same time, that's not a function. So let's actually look at a few examples. So we're going to look at a few examples where one value of x just gives you one value of y. We're also going to look at examples where a function may give the same value of y for different values of x. And we can also look at a few examples of where, it's not a function. So let's start off with a linear function. Y equals to fx equals to x plus 3. Is this a function? Well, yes. And in fact, let's actually draw out the graph for this one. So here, slope of 1 and y-intercept of 1. So you don't have to get it perfect. I just want to draw it accurately. Let's use a different color, actually. And here we go. Y-intercept of 3. And here, x can be any real number. So for instance, if x is equal to 3, well, then you're looking at f3. So what is f3 equal to? Well, for this, you substitute x with 3, so that's 3 plus 3. Now, f3 would therefore equal to 6. Okay? And also, if you did f10, for example, then here you would get 10 plus 3, which is equal to 13. And by the way, for f3 here, for x equals to 3, it's somewhere like here, right? This is x equals to 3. Maybe a little bit here, x equals to 3. And here, if you draw a line, dotted line up to the place of intersection between x equals to 3 and this line, then you get like a point here, right? Now this point has y equals to 6. And this point's coordinate is 3 for x and y for 6. Now 6 for y. So that's how it works in this case. And here for f10, you would get y equals to 13. And in this case, you actually have something called a 1-to-1 mapping. 1-to-1 mapping. So what is one-to-one mapping? What do we mean by this? Well, one-to-one mapping is basically when here the value of x that you input, the different values of x that you input gives you a different value of y. So here, for example, f3 is different from f10, right? And for example, f5 is going to be different from f11, and f7 is going to be different from f8. So for every different value of x you input, you get a different value of y. So that here is a one-to-one mapping. And by the way, this is a function because notice f3, you only get 6. That is your only output, 6. You don't get 6 and 7 at the same time, right? Let's take a look at another example. This time we have y equals to fx. This is equal to x squared. Okay, so here, if x is equal to 1, well then y would be equal to 1. If x is equal to negative 1, well then y would also equal to 1. So these two lead to y equals to 1. And this is allowed because in a function, there's one output for one input. And this is okay because if x is equal to 1, then you only get y equals to 1. You don't get y equals to 1 and negative 1, right? If you were to actually draw the graph for this, so that's a parabola, like this maybe, like this. Okay, so here's a parabola. And let's say that this is x equals to negative 1, and this is x equals to 1. Okay, so you can see here that both of these lead to this level, and this level is at the same y level. In this case, it's y equals to 1. And this here is called a 2-to-1 mapping, and you can probably see why. Here, the two different values of x lead to the same value of y. And you can do, for example, x is equal to negative 2, you get 4. X is equal to negative 3, you get 9. Let's go on to another example with square roots. So, for example, y is equal to fx equals to square root of x. So, what does this graph look like? Well, this looks like this is the positive square root. So if we're only taking the positive, then we're only taking this part of the graph. And is this a function? Well, if you just input, for example, f4, then you get 2, right? Square root of 4 is 2. f9 is equal to 3. And since this is only the positive, we're not writing negative, right? We're only getting the positive value. So it's still just one value for these inputs. So yes, it is a function. f10 is equal to the square root of 10. And for example, f8 would equal to square root of 8, which is equal to 2 square root 2. But we're only getting the positive value. Therefore, this is indeed a function. And there's this something you can call this is something you can call a vertical line test. So if you draw a vertical line, basically this line has the equation x equals to some constant. If constant is any real number and you draw this vertical line, then this line should only intersect the graph at one point, at only one point. Now, of course, here you don't intersect anything here, but that's not the point. The point is that if it ever intersects the graph, then it only should do it at one point. If it intersects at 2 or 3 or more, for example, then that's not a function. And you can also take the graph of the parabola, for example. So here's a parabola. This is a function because for any vertical line that you draw, it's only going to intersect at one point. Not 2, not 3, only at 1. Now let's take a look at an example of where you do not have a function. So for instance, let's say that, let's say that you have y is equal to positive, negative square root. So this time we're allowing for the negative values. Well, let's see. If x is equal to 4, well then what does this give us? Well, y is equal to 2, right? However, we also get y is equal to negative 2. So you can see in this case, for one input of x, you get two different outputs of y at the same time. And for example, if x is equal to 9, then you would get y is equal to 3, and y is also equal to negative 3. And in this case, this is not a function because you're getting one value of x here, you're getting two values of y at the same time. Therefore, this is not a function. Okay, so now that we've learned what a function is and its properties, we can go on to learn the important concepts of a function. The first one is going to be about domain. Domain. And the next one is going to be about range. So, what is a domain? Well, for the domain of a function f(x), the domain is all the possible values of x such that the function outputs a real value. So, we'll take an example. f(x) is equal to square root of x plus 1. Now, what's the domain of this function? Well, what are all the possible values of x such that you get a real value for f(x)? Well, in a square root, the value inside must be positive to get real numbers. So, therefore, we must solve the inequality x plus 1 is greater or equal to 0. Solving for it, you get x is greater or equal to negative 1. Therefore, the domain for this function, f(x), is x is greater or equal to negative 1. And this means that if you don't input a value that is greater or equal to negative 1, you're going to not get a real value. So for instance, if x is equal to 3, well then you're getting f(x), f3 is equal to 3 plus 1, which is 4, and the square root is 2. And if x is equal to 5, if x is equal to 5, well then f5 would be equal to square root of 6. However, let's say that f(x) you put negative 2 in. Well, then this would equal to square root of negative 1, which is not real. Therefore, you can see that if you don't put a value that is in the domain, you're not going to get a real value for f(x). To summarize it with math writing, you must put x, which is belonging in the domain. Okay, now what is the range of a function? The range for a function f(x) is all the possible outputs, all the possible real outputs. So for instance, if f(x) is equal to the square root of x plus 1, well, what can f(x) be? Well, since we're actually taking the positive square root, then we should have f(x) or y. We can write y. Y is greater or equal to 0, right? Because if x is equal to negative 1, which is the smallest value it can be, then it's going to be 0 inside. And from then on, you can get values of y that are greater than 0. But in this case, you cannot have a value of y that is smaller or equal to 0. No matter which value of x you input, there is no way you can get a value of y that is smaller than 0. Okay, so let's take a look at an example of, for example, f(x) is equal to x plus 3. What's the domain? The domain here is x can be any real number. And in this case, y can also be any real number. So any real number is possible for the output of this function f(x). And you can put any real number into this function as well. Now, what about, for example, x squared plus 1? Well, the domain here is, again, x can be any real value. Any real value will give you a real result. However, what can y be? Well, if you take a look at this x squared part, x squared can only be greater or equal to 0, if x is real, of course. Since the smallest value of x squared is 0, and then you add 1, so then that's 1 as the smallest value. Therefore, y can be greater or equal to 1. And that's the range of this function.